Good morning, ladies and gentlemen. Our goal today our purpose today is to recall and use the 4 steps to find the final velocities using our velocity of center of mass. So, in a one-dimensional horizontal system of 2 bodies, the velocity of the center mass of a system cannot be changed by an interaction within the system. So the collision or explosion on those 2 balls running into each other. Velocities cannot change. Looking at a system from the center of mass is called the center of mass frame, ZMF, or as we called it yesterday, center of momentum frame and 0 momentum.
That's like in that computer simulation that we saw where it was the X that was moving. The X was the center of momentum frame, and looking at the 2 objects from that perspective.
And we noticed that the velocities the X didn't change, right? Even when the balls hit, the velocity still
That's right.
did its thing. Okay, we've seen this before. This is in order to find the velocity of the center of mass, we can use this equation.
How could you memorize this equation?
Don't we know the momentum equation, yes?
Yes.
And it's kind of like taking an average.
Well, what do we got on the top?
Well, this is the total momentum, essentially.
Yeah, the
right?
mass times velocity, the momentum of the one thing plus that's a total momentum. And what's on the bottom?
Just the total mass. So total momentum over total mass.
Can you memorize that, boys and girls?
They can
Because
do it.
this will not be on the AP equation sheet.
But it very well might be on the AP test.
That's right.
Or the exam.
Well, you might need to use it. Here are the steps.
Okay, so to find, the first thing you gotta do is find the velocity of center of mass.
Using that equation we just saw.
Then you're gonna put into CMF, subtract this number from each. So we're gonna subtract this number from the original velocities.
Yep.
Collisions occur, change the signs of each. So once the balls hit, now they have to go the opposite direction. So the velocities that we got up here, we just change the sign.
Now, one thing that could also be an explosion, collision
Yes.
or explosion, and that's my bad. I should have had that.
And
on.
the explosions when we did the
Boom! We threw on the skateboard.
yeah. Put back in lab frame. That just means that we add the velocity of center mass back to each.
So you find the center of the mass, velocity of the center mass. You subtract it from their original velocities. You change the sign, and then you put the velocity of the center mass back in each.
It's all the back and forth flip flopping. Okay, use the CMF to solve problem 46 on page 194.
Page 100.
So pause the video, see if you guys can do it. 46 on 194.
All right.
And here we go.
Good luck. Rolling.
All right, welcome back, you guys. Let's go ahead and talk about how to do this. Here are my 2 masses, and I said, whenever you aren't given a mass, you can just make up the mass, and why not make it 1?
I like 1.
So we're gonna make our masses both 1 kilogram. Woohoo! And this one's going 7 meters per second in the positive direction, and then this one -4 meters per second in the negative direction. Now the very first thing I did was calculate the momentum before, and this is just mass 1 v1 plus mass 2 v2, and I get a total momentum of 3 kilogram/meter per second.
Okay, so that's what we're starting with. Now let's.
So now the first step, you have to find the velocity of the center of mass. That is right here. Okay, this is our total momentum divided by our total mass. That's our equation we use, and we get a positive 1.5 meters per second that way.
Okay.
Second step, we take that the velocity center of mass and we subtract it from the initial velocities we have. So 1.5 and 7, and then 1.5 minus -4, or -4 minus 1. You get the point. And I get my answers. Okay. Third step.
Third step.
Change the sign of each. So I make this negative and this positive.
Oh, that's simple.
Easy. And then my 4th step, put them back in the lab frame by adding my velocity center of mass back to each. So I switched the sign, and then I added my velocity center of mass back to each. -4, and 7. So
That's the answer.
this means that the velocities, remember, overall the velocities are unchanged. So this one is going -4 meters per second that way after they collide, and that one's going 7 meters per second that way after they collide.
Did you get these answers?
Hopefully.
And now you can check to see if it's right. The momentum afterwards,
So the momentum after should equal the momentum before. So when we put everything together, it should also equal 3 kilogram meter per second. So 1 times -4, -4. 1 times 7 is 7. -4 plus 7 is 3 kilograms meter per second. And this is our check. And we use our velocities with this, and it works out because that's what we had before. And we had before and after, it needs to be the same.
so what we've just done is solve a problem for two unknowns. We knew the original conditions for both, but we didn't know one, so it would make it easier to solve for the other. So that's the beauty of this velocity of center of
The
mass.
strategy here. So we found the velocities after the collision for both of the balls, which we didn't know both of them.
That is no small feat.
Okay, so we did this
We've already
one.
done that one.
Okay, go to page 183 now. And wrong way. 183, and you're gonna look at example 7. Now, when you get here, don't look at the solution yet. Rather,
If you can go ahead if you want to, but you'll hate yourself.
it's not gonna be fun. So you're going to just answer the question. I'm sorry. So you're gonna read through, and you are gonna use the ZMF, what we've been talking about, to answer the question.
Read this. When it gets to reasoning, stop. Don't read any of this other stuff. Believe me.
This is not what we've been talking about. We use what we just talked about, this strategy, to answer this question.
Go ahead.
Do it. You guys done yet? Okay, so here's my solution over here. What we did was step 1, we found the velocity center of mass of positive 1.190, and we subtracted that final velocity mass from the original velocity, getting us these numbers. And then from there, we changed the sign, so from positive to a negative, from a negative to a positive. So they're going the opposite direction.
Yeah.
And then we add back the velocity center of mass, and then we get our answers. So at the very end, this one is going this speed that way, and that one's going that speed that way. Now, how does this compare to the answer in the book?
Here, you get on this side.
What's it next? So I want you guys to now read the entire example 7, from on this page 183 to 184. Take a look at this.
That's your
Start
homework
here.
assignment.
Yeah, start here, go through the reasoning. Ooh. Whoa. Don't forget down here. And notice the answers. Negative 2.62.
-2.62. We got that one over there.
Positive 2.38.
We got that one over there.
Okay, so
Which method would you prefer?
what do you want to do? This will be your homework, a quick little write-up.